Pre-algebra students. Hello. Mr. Lawrence here with your flip lesson. And remember, we're getting ready for algebra next year. Remember, algebra is going to be a pretty challenging course. I'm trying to set you up to be successful. We've got a few more days that we have to push through here. We can't take it easy until we're done, guys. Not done yet. I know you think you're done, but you're not. All right. First of all, today's goal will be for you to say at the end, I can multiply monomials. Now, monomial just means kind of like one term, okay? Like I'm going to multiply 3 times 3. Now, I know all of you are going, hey, that's 9. But I'm wondering if you know a different way to say 3 times 3. Could you maybe say it like 3 to the second power? Does that sound familiar? Yeah. And of course, 6 times 6 times 6 would be 6 to the third power, right? Okay, and then these 5 11s multiplied together would give me 11 to the 5th power. Now that's very important because if I ask you what x times x is, and you try to tell me x, you aren't making any sense. Look, 3 times 3 is 3 to the second power. X times x must be x to the second power. Yeah, of course. This number here, the exponent, tells me how many of the base, in this case x, are being multiplied together, right? Take a look at 6 times 6 times 6. There's a 3 here. That tells me there's 3 6's being multiplied together. So when the bases match, I'm just counting up how many there are. Well, what do you suppose x to the 5th times x squared would equal? Well, doesn't this mean that there are 1, 2, 3, 4, 5 x's being multiplied? And doesn't this one mean there are 1, 2 x's being multiplied? Well, how many x's are being multiplied all together? Well, 7. Yeah. Hey, look at this. There's 5 here and 2 there, and then I get 7. 5 plus 2 is 7. Coincidence? I think not. Let's look at another example of that real quick before we get to our actual problems here. How about if I had x to the third times x to the, I don't know, fifth? Well, this would mean that there's x times x times x, right? 3 x's being multiplied together. That's what x cubed means. And this one would mean that there's 1, 2, 3, 4, and 5 x's being multiplied together. Well, how many x's are there? 1, 2, 3, 4, 5, 6, 7, 8. There's 8 x's all together. 8, what's 3 plus 5? 8. Yeah, so when the bases are the same, if I'm multiplying like bases, I can add the exponents. When multiplying like bases, I can add the exponents. When multiplying like bases, I add the exponents. And, you know, that works for even like regular numbers. If I do 2 to the third times 2 to the second, I'm suggesting that's 2 to the fifth. And I'll prove it to you. 2 to the third would be 8, right? 2 times 2 times 2 is 8. Some of you are thinking 6. You're incorrect. 2 times 2 is 4 times 2 is 8. And 2 times 2 is 4. And 8 times 4 is 32, right? Well, 2 to the fifth, if I do 2 times 2, I get 4 times another 2. Now I'm up to 8. So there's 1, 2, 3 of the 2s so far. And I multiply by 2. Now I'm up to 16. And if I multiply by 2 again, I get to 32. Look at that. Okay. So when I multiply like bases, I add the exponents. Now the problems we're going to do are a little bit more complex than that, but they're not really difficult, just a little bit more complex. And let me show you what they look like. And let me get rid of that ugly thing there. Say we're going to have 5x squared times 3x to the fourth. Well, this is super duper simple. First of all, you're going to multiply the coefficients. 5 times 3. Second of all, you're going to multiply the like bases. The x's in this case. So, let's see how that works. Oh, 5 times 3. Dun, 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 that's a hard one. 15. X squared times x to the fourth. Well, there's 2 x's here. There's 4 x's here. How many x's are being multiplied? 6. 2 plus 4 is 6. There you go. Let's try that on this one. Example number 2. I've got to multiply my coefficients. Then I have to multiply my bases. Right? The bases that match. So, get back to my pen here. 2 times 5, that's 10. Now x times x to the 6th. Before you tell me it's x to the 6th, stop and think. How many x's are being multiplied? There's an x here, and there's 6 x's here. How many x's altogether? 7. Now some of you are like, well, Mr. Lawrence, you told me to add the exponents, and I don't see an exponent here. I see an exponent there. A plain old x. Doesn't that mean x to the first power? Isn't this really x to the first times x to the 6th? And 1 plus 6 is 7. There you go. So when you don't see the power, you assume it to be a 1. You can put that little 1 in there if you need to. All right. So this problem here looks a little bit longer. Well, 8's a coefficient, 3's a coefficient, and 2's a coefficient. I'm going to multiply those together. Then I'm going to multiply an x squared, an x to the 4th, and an x. And some of you are going, Mr. Lawrence, there's that plain old x again. Don't freak out. Just put a 1 there. It's okay. So now I'm going to multiply 8 times 3 to get 24 times 2, which is going to be 48. And then I'm going to multiply x to the 2nd times x to the 4th times x to the 1st. Well, 2 plus 4 is 6, plus another 1 is 7. X to the 7th. This is too easy. Can't believe how simple this is. All right, we'll try this one. Then we're going to try one that's a touch more complex. Okay, let me get my highlighter out. Highlighter, where are you? Okay, I've got an 8, a 10, and an 8, both coefficients. Do I have coefficients here? You don't see them, but when you don't see it in multiplication, you can assume them to be 1. Won't matter in this problem, but you certainly can do that. So this is really the problem. 10 times 8 times 1 times 1, which ends up being 80. Now I have to multiply my like bases together. So I have an x, another x. Remember, x times x is x squared, an x to the 5th, and an x cubed. Wow. How many x's do I have multiplied? Well, there's 1 here. There's 1 here. Up to 2 plus 5 is 7 plus 3 is 10. Oops, sorry. X to the 10th power. 80 times x to the 10th power. Where did I get? I multiplied 10 times 8 to get 80. Times 1 is still 80. Times another 1 is 80. And x times x times x to the 5th times x cubed. X times x times x to the 5th times x to the 3rd. Well, bases are the same, so I add the exponents, and I got x to the 10th power, because 1 plus 1 plus 5 plus 3 is 10. All right, now, if we had a more unusual one like this, where you have maybe 2x to the 4th y cubed, and we were going to multiply it by 5x to the 6th y to the 2nd, it's the same problem. It's just a step longer. There's nothing hard here. Look, my coefficients are 2 and 5. I'll multiply those. My x is x to the 4th and an x to the 6th. Then I have my y's. So I'm going to multiply. 2 times 5 is going to get me 10. X to the 4th times x to the 6th is going to equal x to the 10th. And then I have my magenta ones to get me y cubed times y squared. The bases are the same. I'll add the exponents and I'll get y to the 5th. Y to the 5th. And there you go. That's how simple it is. All right, we're going to get a little more practice with this in class on Tuesday. Trying to get you guys ready for algebra. Mr. Lawrence signing off. Good night, everybody.